Folks, hello and welcome to week 9. This is the second half of the practical exam. A little video I wanted to follow up with after last week where we went through the options that you have to complete the practical and the information that we were looking for during week 8. And for week 9, this now becomes the computational and the computation, the analysis, and the interpretation in order to finish this up. So what I thought I would do is, again, take a look at the three options that I've kind of translated from aviation, and I've got some baseball. I think I said some data from some second basemen that I've kind of come up with here to make sure that everybody understands how you're going to do this in Excel, depending on the option that you are pursuing for the practical. So let's see, just as a reminder, what I put over here, option 1, option 2, option 3. Remember, option 1 is comparing a brand against a hypothesized mean. The second option is comparing two manufacturers. And then the third option compares one company performance pre-calibration and maintenance, and then compares that to a post-calibration and maintenance performance to see if the average error on the altimeter has changed, depending on how you want to write the hypotheses there. So let's see. For option 1 here, if I'm comparing one brand against another, remember what I did is I said, hey, here's for the 30 teams of Major League Baseball, here is the batting average for, there might have been a combination of guys who played second base, but for each team, there's the batting average. And here's a historical mean that I'm going to assume of 265. And if you notice over here, what I'm assuming in the null hypothesis is that there is no change from last year to the hypothesized mean. And then I just want to see if perhaps this group changed against or compared to the historical mean last year. So that's based on this setup. It should be clear that this is a two-tailed test. Now, when I get to these other two options, option 2 and option 3, I can actually use Excel, the data analysis tool pack. If you don't have that loaded, I'll show you how to get to that here in a second. But I can actually use that tool pack and go through this quite simply. More on that when we get there. But for this, there is no tool in Excel that you can just go point to, enter some data, and get a result. So what you're going to have to do is you're going to have to compute. If you recall, when we looked at z-scores, this is going to be the equivalent of a z-score, only it's a t-score because you don't know the population standard deviation, and this may still be on the, typically 30 is a sample size that we like to see to assume that a distribution follows the central limit theorem, but we'll just keep this as a t distribution approach since I'm not using, or I don't know, the population standard deviation. So in order to compute this test statistic, come up with a p-value, and assess the scenario, obviously you get the altimeter problem. What you're going to need is the sample mean, the sample standard deviation, the sample size, the standard error of the mean, which is just the sample standard deviation divided by the square root of the sample size. The number of degrees of freedom, that comes into play here when we start getting into the t-distribution, and then the hypothesized mean. The test statistic here, which again is going to look very much like a t-score. Let me actually put my cursor in there so you can see the computation. So once you go through and you compute all these values here, these values, to compute the test statistic, you're simply going to take the difference between the sample mean, which is 269, the assumed mean of 265, so E9 minus E14, I've got 265 down here as well, and then divided by E12, which is the standard error of the mean. Again, that's computed by taking the ratio of the sample standard deviation to the square root of the sample size. This will give you the test statistic. And then the last step here is if you open up this cell here, what you'll see is I've got some Excel syntax in here. So if you type equals and then t.dist, this will get you into the Excel functions. And this particular t distribution function T.dist.2t gives you the two tail or the areas in both tails summed for a distribution where the test statistic is 1.414 and the number of degrees of freedom is 29. And so from that, you can take that p-value and you can draw your conclusion. Obviously, if you're working this problem over here, option 1, where you're comparing the averages of your data to some hypothesized mean. So no issues there. The second one here is comparing one brand against the other. So what I did is I took about half of the data, split it up into the American League, the other half into the National League. And the assumption I'm making here is that there's long been this notion that the American League hitters are better than the National League hitters on average. So what I'm going to test to see is in this year, did the National League statistically outperform the American League? So this is, even though the number of samples is the same per group, this is a 2-sample test. So let's see, I don't know if I'll be able to get to this. What I'm going to do is I'm going to show you first. If you notice on my Excel software here, if I click on data and I go all the way over to the right here, I've got something called data analysis. And this is the data analysis tool pack. If you go to data and you don't see the tool pack loaded over here, here's what you need to do. Go to file and then go down to, let's see, options. And in this left-hand column, go all the way down to add-ins. And then at the bottom of the page, you'll get an opportunity to add some additional Excel functions that are inherent to the software. As long as it's clicked, or as long as Excel add-ins is chosen, just click go. And of these 4 options, make sure you click on the data analysis tool pack. I've got a solver add-in here, which is for another class, but this analysis tool pack, just make sure you click that and click OK. And then if you recycle your software, you should then see, let me click this back. So, yep, I think we're in good shape. So just recycle your software and then go over to the data analysis tool pack. If you click here and you go down through the options, there's a lot of good stuff here. At the very bottom, you've got a series of t-tests that you can choose from. And remember we said here, this is a 2-sample t-test. So I'm going to go, let's see, 2-sample, assuming, and we can assume equal variances. That'll be fine for this. And then click OK. And then, let's see, let me start this from scratch. So the add-ins here, or the inputs here, will be the variable 1. So that's going to be the American League batting averages for the second baseman. And then the variable 2 is going to be the National League. And we'll enter those. And we're going to assume that there is, we're going to assume the hypothesized mean difference is 0. There are no labels. I just got the 15 data points per league. And then I'll assume alpha is 0.05. And then all you need to do is choose a cell in the sheet. I typically do that instead of having to work between different sheets. So if you click on output range and then put your cursor in there, and then I'm going to put these in cell, or start them in cell Q20. And then just hit OK, and then you've got everything you need to know here. Let me widen this out just a bit. Yep. And so let me just make it clear here. When you put this in Excel, the variable that you use first and then the variable you use second, when you subtract these 2 values, it's always going to take this variable, it's going to take this variable and subtract from it this variable. So that may or may not matter to you as you set up your hypotheses, but make sure that you understand that is how Excel is going to report results. For example, you can see, let's see, it looks like the American League average was 267, and the National League average was about 269. So that's why the test statistic here, this is obviously, this difference is what goes in the numerator. So this test statistic is negative because of that. And it's, again, because it starts by subtracting whatever you put in first, or you subtract from the first the second. So this minus this goes in the numerator of your test statistic. So let's see, choosing equal variances, that I think that's okay. 15 observations per. The hypothesized mean is 0. Because we have 30 data points but 2 samples, the degrees of freedom is going to be, let's see, n1 minus 1, n2 minus 1. So that's how you get 28 degrees of freedom. The test statistic is here, and the p-value, I'll just say here's the p-value. I'm sorry, here's the test statistic. Based on the way the hypotheses are set up, you can tell whether or not this is a one-tail or two-tail test. And here are the associated p-values, and then you can use those to draw your conclusion. But that is the mechanics for running a 2-sample test in Excel. The last one here, remember, is this would be the one where you're comparing one altimeter to it, basically to itself, after some adjustments to see if the performance has improved. What I'm doing here, there's this notion in baseball that when guys reach free agency, there's some performance level in that year. And then after they sign the big contract, that the performance decreases. So that's what I want to test here. Or actually, that's what I'm going to assume here, is that after the player gets paid, after he gets that big paycheck, that the performance in the post-free agency year is going to be greater than that of the pre-agency year. So I have set that up accordingly here in my null hypothesis. And what I'm going to test to see, is it really the case that the player actually underperforms, that being that the pre-free agency average is greater than the post-free agency average. So if I go back to data analysis, the option I want to choose here, this is going to be a paired 2-sample for means. And I'll click OK. And I think I've already got my data here. I'll just do it one more time. So I want this as data, or as variable 1, this as variable 2. I'm going to assume the mean difference is 0. I'll use 0.05 as alpha. And I'm going to use the same output range. I'll just have to click and say it's OK to overwrite. So let's see, I'm going to look here. Variable 1, variable 2, remember it's in the test statistic, it's going to be this variable minus this variable. So you can see the test statistic, 1.78, that's interesting. And then you can see the p-value for a one-tail test, p-value for a two-tail test. The only thing you need to decide is whether this are one or two-tail, and where you would reject the null hypothesis, in the upper or the lower tail, depending on the way you set up the hypotheses. So I hope that helps. I will post this for you, and I'll look forward to seeing all the great work later this week. Take care, and let me know if you've got any questions.